this video, you will learn that in two quite different ways, the burning of fossil fuels can cause our rain to be acidified. Sulfuric acid arises from the burning of coal and oil mainly in the power stations, while nitric acid arises from the exhaust pipes of our motor vehicles. You will also see some of these effects that acid rain has on our environment. Firstly, you have to understand that rain is naturally slightly acidic. Whilst falling to the ground, the rain dissolves carbon dioxide from the atmosphere to form carbonic acid, a weak acid giving natural rain a pH of 6. It is when we burn fossil fuels that much stronger acids get into our rain to form the acid rain with the pH as low as 3. So when the pH changes from 6 to 3, what do you think the acidity increases by? 2 times, 3 times, 10 times, 1,000 times? Pause and think. Remember that each change of 1 in pH is 10-fold change in acidity. So changing from 6 to 3 is 10 times, 10 times, 10 times, or 1,000 times more acidic. We will consider sulfuric acid first. Plants need a little sulfur to grow. They obtain it from sulfate, for example, potassium sulfate, found naturally in the soil. The sulfates are taken up by the plant's roots and sulfur atoms become bonded to carbon atoms in the leaves, protein. When plants die and eventually form coal and oil over millions of years, these sulfur atoms remain bonded to the carbon atoms. So the sulfur content of coal and oil is between 1 to 4% by weight. What is produced when fossil fuels containing sulfur are burned? Pause the video and think. When the coal is burned, the sulfur and the carbon atoms join with oxygen from the air and are released into the atmosphere as carbon dioxide and sulfur dioxide. In the presence of sunlight, a photochemical reaction will take place where sulfur dioxide reacts with more oxygen to form sulfur trioxide. This dissolves in rainwater to form sulfuric acid. So let's now consider how nitric acid gets into the rain. In the high temperature conditions, in the cylinder of our motor vehicles, a small amount from nitrogen and the oxygen can react. Remember that the air taken in to combust the fuel is nearly 80% nitrogen. So exhaust gases from the vehicles contain small but significant amounts of nitrogen oxides. Once the oxides of nitrogen are in the air, they react with more oxygen atoms, just like we saw with sulfur dioxide, and dissolves in rainwater to form nitric acid. If the rain falls on limestone soils, which are alkaline, the acidity may be neutralized. However, if the rain lands on neutral or acid soils or on vegetation, then it can cause damage. So why is this acidity harmful for living things? Well, living things cannot grow well in acid conditions. It's easy to demonstrate this. Soak a slice of bread in vinegar and another in pure water, leave them open for a little while and then leave them covered in for a week. You will actually find that one soaked in vinegar has not gone moldy where the other bread has. In fact, we use vinegar to preserve food in a process called pickling. This is the case because certain enzymes which are vital for the growth are unable to function in acidic conditions. The other main problem occurs in the soil because of the toxic metals such as the aluminium becomes insoluble, therefore fairly harmless in neutral soil. They become soluble in acidic soil, they then get taken up by the living things and taken the place of essential metals such as the zinc and iron. To add to this, the hydrogen ions in the acid rains will replace essential metals ions such as potassium, magnesium, calcium, which are normally held in the clay soil, causing these essential metals to be washed deep into the subsoil away from the roots of plants. So to summarize, the normal rain is slightly acidic due to this dissolved carbon dioxide, but acidic rain contains sulfuric and nitric acid, making the rain 1,000 times more acidic and dangerous. Sulfuric acid arises from the fossil fuels containing sulfur, and nitric acid arises from the combustion of atmospheric oxygen and nitrogen in the high temperature conditions in the cylinders of petrols.